This is ANT327, what's new in data streaming on AWS. My name is Ashish Palekar. I take care of our managed Kafka and managed Flink services here at AWS. And what that means is I talk to customers, understand sort of what we're trying to do, help us get to the right product, right feature set with the right quality bar. And so super happy to have this conversation with you today. With me, speaking later on will be Anusha. Anusha is the principal engineer with the MSK team. And then later on, we will talk to Sagar, and Sagar is an associate director with Verizon. So here's how the session is going to go. We'll talk a little bit about the portfolio. We'll work through how we think about what is important in streaming, and this will help set the mental model on what we do and how we launch features and things of that sort. We'll talk about key launches across the streaming portfolio along the lines of what we think is important, and then we will hear from a streaming customer. We have a lot to cover today, so at the end of the session, we'll be happy to take questions, but let's get going. In general, and the reason I suspect all of you are here in the streaming session is streaming data technologies are a way to get enormous value for your organizations today. And this really comes from customers looking at 4 different models. They want to harness all their data from real time. You want to optimize and reduce your costs. You want faster insights, better analytics, and therefore better decisions. And then customers are also using streaming data technologies so as to keep systems updated and synchronized. And these are all big ways that customers consume our streaming data technologies. To tackle these, and especially because as we see data aging over time, losing value over time, we have a set of technologies within AWS that we use for these purposes. So we think of it as ingestion and storage and processing, and then connect our end-to-end technologies. But in ingestion and storage, we have Amazon Kinesis data streams, KDS. And then we have Amazon Managed Streaming for Apache Kafka, which is Amazon MSK. In terms of stream processing, we have our Amazon Managed Service for Apache Flink, MSF. And then to sort of do the end-to-end streaming or to connect from sources and various sources and destinations, we have Amazon Data Firehose, and then we have Amazon MSK Connect. And so that is the set that we will cover in the discussion today. And these streaming services are used by a wide array of customers. And really, we're enormously thankful to all these customers and more. Give us input, give us feedback. Talk to us about what's important, what to go build, and in general, help us shape the direction of our services. So again, we wouldn't be here without their help. So thanks to them. Let's look at one such customer. In this case, it's Mercado Libre. For those that don't know, Mercado Libre is one of Latin America's biggest e-commerce customers. And what they do is really sort of try to bring value in terms of various use cases that they do. The problem that they faced was they had over 30 million incoming messages and 50 million outgoing messages. And they have to do this in order to process 17,000 payments, items, shipping databases. And they wanted to ensure that they're reaching the destination within 1 second. And they really needed to maintain a very high SLA. So in order to solve the use case, they integrated with our Amazon Kinesis data streams, and they integrated into their internal platform known as Fury. And in Fury, what they're able to do is bring KDS in and be able to build around it, be able to replicate, make sure that they're providing a uniform interface so that developers can integrate with it. And with that, they're able to tackle their workflows in real time across payments, items, shipping, authentication, fraud, machine learning, and analytics. And what is the outcome that they got? Because of this, they were able to increase their SLA and uptime across the board to about 6 nines and provide consistent and reliable data replication across regions to their customers. So again, at scale, using our services to provide a high uptime to their customers. And that is the pattern, right? Like the thing we see with customers is we see 4 ways that our customers are consuming streaming services. First is for real-time analytics. The customers are using it in order to take their data that is coming in real time, process it, get results, and close from there. Then it's real-time data transformation. Data comes in, convert it into formats, either sliced data or enriched data. Next is ingestion into a data lake, taking it and consuming it into a broader data lake. And last but not the least, for event-driven architectures. And across the board, over the last 12 months, 18 months, what we've started to notice is streaming workloads are increasingly becoming mission critical to businesses. And that aligns with the example you're seeing with Mercado Libre, but also as you'll hear Sagar talk about, that is important as workflows are evolving and are changing over time. And so when you now think about what is mission critical and what things would be important to customers in streaming, we really think about 4 items. It's performance, and specifically there's the unit of performance in terms of per scaling, but also the number of units. In general, higher performance is better. It's cost. What is the overall cost of the solution? In general, as you can imagine, lower is better. Resilience, what is the availability? How easy is it to build resilient applications? That becomes important to customers. And last but not the least, it's ease of use. Specifically, what is the time to value? What is the ease of integration? What is the ease of operations? And these are things that are enormously important to our customers. We will cover all of these through the session. Anusha will focus on availability and ease of use, and I'll take the first 2. And the reason for that is often performance and cost go hand in hand. What does that mean? You can improve performance while keeping costs constant, or you can improve cost while keeping performance constant. And so in general, these go hand in hand, and that's how we will talk about it. Let's start with performance and cost. So very recently, we launched the Kinesis client library, KCL 3.0. This is a new consumer library. So prior to KCL 3.0, what would happen is you would have uneven utilization of EC2 instances. Specifically, as they're processing data, you could have instances that are running hot, instances that are running cold, but in general, you didn't have a well-balanced distribution of that processing. And the impact of that is that you often had to provision your instances on the client side for the peak. With KCL 3.0, you will get a much more balanced workload across these 2 instances. And the result of that is you can reduce the number of CPUs you need to process that information because it's evenly distributed. In our data, in our analysis, it can lower your compute costs, and we have seen the ability to save up to 30% for customers. Furthermore, with Java 2.x support, you will also get better performance. So in other words, again, you're getting both the cost benefit, but also the performance benefit. So we're pretty excited about what KCL 3.0 can do to our Kinesis customers. For our Flink customers, this was a change that we launched very recently. We used to do per hour billing. And what that meant is if you had 15 minutes of usage, you would be billed for the entire hour. And one of the changes that the team has made is now for 15 minutes of usage, you'll get charged for 15 minutes. So we've gone to per second billing. There is a 10-minute minimum. And this question comes from customers a lot. There's no change in the pricing. It is the same hourly rate, but applied in 1 second increments. And so from that perspective, it is the same hourly rate. So to a lot of customers who are using Flink and have jobs that don't run on an hour boundary, this is savings for you. So again, you'll see it directly in your bill. So we talk about performance and cost, but once in a while, you get the ability, you have sort of the opportunity to launch something that affects all 4 of these characteristics at once. And that is Express Brokers for Amazon MSK. We launched this in November, and I'm pretty excited about what this can do for our customers. So what's the origin story for Express Brokers? We love Kafka. This service team at MSK has been operating Kafka for over 5 years. We've seen workloads of varying sizes, large, medium, small, operating different kinds of workloads and a breadth of workloads. And one of the things we kept asking ourselves is, how can we make Kafka run better on AWS? And so the team has been trying different ways to sort of figure out what we can do better or differently. Our first step was tiered storage. In partnership with an external partner, we built tiered storage. We GA'd this in October of 22. And in tiered storage, what we were able to accomplish is that effectively create storage that was local as well as remote. The remote storage was shared between brokers, and that helped us accomplish a certain set of characteristics. Specifically, it helped us reduce the cost to retain data by 60%, by up to 60%. You got unlimited pay-as-you-go storage, and customers got storage elasticity. So we're very excited about what tiered storage can do. But it's equally important to acknowledge what tiered storage doesn't do. What tiered storage doesn't do is it doesn't address the storage management overhead. What do we mean by that? You still have to provision local storage. You have to think about, do I have the right amount of local storage? What if I run out of local storage? Does that change over time? It doesn't solve resource coupling within Kafka. And that is especially important, and later on Anusha will cover this. But if you think about what happens when there's rebalancing in Kafka, and how that affects what's happening on your producing and consuming side, that is what we're referring to when we say resource coupling. And last but not the least, it doesn't give you compute elasticity, the ability to add or remove nodes quickly and change that arc. And that is something that the team has been reflecting on as just observations we had, but also feedback from all of you, which is, hey, we love what tiered storage does. Can you do more? And so we asked ourselves, what if we eliminated the storage management overhead? Right? Decoupled resources in Kafka, optimized for compute elasticity. And by the way, because we've been operating Kafka for a number of years, used the learnings to implement our Kafka best practices by default. The combination of these 4 things is really Express Brokers for Amazon MSK. So what are the outcomes? What does this actually mean for you as customers? Right off the bat, it delivers up to 3 times the throughput of Apache Kafka brokers. Right? What does that mean? So let's look at something what we launched at re:Invent last year, which is the M7G. Across the spectrum, the current brokers that we have, they're called standard brokers. And you'll see the sustained throughput across those brokers. What do I mean by sustained throughput? So it is possible. Actually, we do have customers who will say, yeah, we can do more than this. The problem with doing more than this throughput with these brokers is when failures happen, if your workload spikes, if you have unexpected rebalancing that happens, now suddenly you're scrambling. And so we have this concept internally of this is kind of what you want to run for your throughput. Here's what happens with Express Brokers. Across the board, you see improvement. And actually, you see far more improvement as you get above 8x large and beyond. And so I want to call attention to actually look at what happens at the 8x large and beyond for standard brokers. It almost flattens out. And the reason for flattening out is it then means that there's a rate limiting step somewhere else. Whereas on Express Brokers, you're able to get the full underlying entitlement of your infrastructure. And so that's what 3x throughput means. Suddenly for you as customers, that means you can consolidate down to fewer brokers, and hopefully that saves you money, but equally importantly, improves your posture relative to what you have as a workload. So that's at the performance end. Let's look at elasticity. Express Brokers give you up to 20x faster scaling when you compare with Apache Kafka. And just like with tiered storage, you get virtually unlimited pay-as-you-go storage. So we retain that quality. From an availability standpoint, you get 90% faster recovery compared to standard Apache Kafka brokers. And in fact, because we have implemented best practices by default, that also means that especially if you're a central IT team providing a Kafka service to your customers, you now have the ability to implement these best practices across your applications. And finally, because we have resource separation, you get better improved failure handling. What about ease of use? We fully manage the storage. So you pick a retention period, and the storage infrastructure is fully managed for you. The next one is my personal favorite. There is no maintenance window for patching. Right? It fundamentally changes what your Kafka experience is. And because Express Brokers deliver elasticity and because they deliver faster recovery, it means that these are easy to size and adjust as your workloads change. And so really, it's a set of these 4 characteristics that we get excited about. So what does pricing and availability look like? Actually, before that, we'll cover when do I use Express Brokers? Because that's a logical question that follows is, when would I use Express Brokers? So we look at it on sort of the 2 broad arcs. One is customers that want more Kafka control, and others that want more Kafka automation. So on the left-hand side, you have the standard brokers for Amazon MSK. This is if you are migrating from an existing Kafka setup. You need fine-grained control of Kafka. And you have deep know-how about what Kafka is, how it works, what your choices are, and trade-offs. And those are important considerations when you're thinking about using standard brokers. More Kafka automation, we have Amazon MSK serverless. Here, you're really not broker-specific. You can quickly deploy and scale up and scale down Kafka. There's no Kafka management. We do partition rebalancing for you. And honestly, this is for workloads where you don't need or don't actually want to know about the nuances of Kafka. Express Brokers is somewhere in between. This is for workloads where you value performance and elasticity. You want lower control than standard brokers, but slightly more than you get with serverless. But at its core, this is really for operating your Kafka services at scale. And so when you're thinking about large-scale Kafka services, either multiple clusters or single large clusters, this is the thing that we would go. In fact, unless you know differently, and sometimes that is the case, you may know more nuances about your workload. Express Brokers is a good place to start for your Kafka workloads. So what does pricing and region availability look like? So here's the pricing on US East 1. We have the standard broker charge. We have a storage charge. And actually, the storage charge is interesting. In standard brokers, you'll pay a storage charge per attached broker. In this particular case, because it's storage that's managed by us, we will take care of managing those capabilities underneath, and you're paying one price. And so that should result in savings for US customers. And then we also have a data in charge, which helps us better align with how your workload is changing. It's currently available in 8 regions, and the team continues to work fast and furious to roll these out. So that's on our performance and cost angle. To help us walk through what all our launches mean in terms of availability and ease of use, I'd now call Anusha to the stage. Anusha, take us through the rest.
Thanks, Ashish. I'm Anusha. I'm a principal software engineer with Amazon MSK, and I'm continuing on the theme of what's important to customers. Let's talk about availability. So streaming services like Apache Kafka and Amazon Kinesis are the backbone of data processing across businesses, and they power everything from live analytics to instant notifications. They help applications handle massive amounts of data with ultra-low latency, and that makes real-time insights a reality. So what makes streaming services highly available? According to me, there are 3 important pillars that we continuously innovate to get right to deliver this experience for our customers. So let's look at what they are. Broadly, I categorize them as impact detection and avoidance, real-time responsiveness, and redundant systems. Let's unpack each of these a little more. The first critical pillar is impact detection and avoidance. Now, I'm closing in on about 10 years of being a software engineer on AWS, and I can tell you that building a system to avoid impact begins long before we deploy software to production where it reaches your systems. It's rooted very much in the design phase for us. Every time we design a feature, we think about all failure scenarios, no matter how unlikely, and make sure the system is able to detect and mitigate them before you see impact. Let me tell you how we got to do this in a recent launch in our MSK service. So earlier this year, we launched the capability in MSK to remove multiple brokers from your cluster. Now, if you think about it, especially in something like MSK Express brokers, this is very valuable because you can take advantage of the 20x faster scaling that Express offers to scale up and scale down your clusters during your peaks and valleys and optimize for costs. But there was an important challenge here that we had to solve for before we could get this feature into your hands. Let me explain it with an example. So let's say I have a cluster with 6 brokers, broker 1 through 6. And as many of you Kafka users might know, a bootstrap broker string is a way in which the Kafka client discovers the topography of the Kafka cluster. It doesn't help with production or consumption of data, but it's super critical to get started with your application. So let's say I want to take advantage of the broker removal capability, and I remove 3 brokers from my cluster, 1, 2, and 3. But looks like I forgot that 1 through and 3 are also my bootstrap brokers in this setup. So I have successfully made sure that my applications can no longer bootstrap with my cluster. As a customer, if I had to avoid this failure scenario, I should have made sure to update my client before I went and updated, or rather removed the brokers from my cluster. And you can imagine, at an enterprise scale, you could have hundreds of clients, so it's practically impossible for you to go and make sure that you're updating every single one of them. So failure is almost unavoidable. So we thought about this, and when we built this feature, we made sure that we seamlessly mapped every single broker you remove to a live broker in the cluster, so you can continue to optimize for costs while not taking an availability impact. Let's talk about the second pillar, real-time responsiveness. Streaming services often deal with fluctuating data volumes, such as sudden spikes during traffic or during peak events. If the system cannot quickly respond by scaling up resources or distributing the load, you would experience delayed data or even data loss. So we have 2 impactful launches that I want to talk about in this dimension, so let's dive into them. First, a Kinesis on-demand stream can now support up to 10 gigabytes per second write throughput and 20 gigabytes per second read throughput. This is massive and over 5 times the throughput that we delivered for you at the same time last year. You can now take advantage of the operational simplicity that comes with a Kinesis on-demand stream and pay-as-you-go pricing model to host even higher throughput workloads. Now let's talk about how MSK delivers on this critical dimension of real-time responsiveness. So earlier in the talk, Ashish introduced Express brokers and how they scale up to 20 times faster. But what does that really mean? What does scaling even mean for a Kafka broker-based setup? So when you have a current setup of instances or brokers and you want to scale for a peak or a traffic event, the first response is to add new brokers. But it doesn't end there. It's not only important to add new brokers, but you have to go equip those brokers to handle the new traffic that is incoming into your cluster. And that directly translates to rebalancing topic partitions from your older brokers to the newer brokers. So scaling speed in Kafka really means how fast can I rebalance my partitions after I add new brokers while the traffic is still continuing to climb. So I wanted to test how standard Apache Kafka brokers performed when compared to Express brokers in reality. So I took an average case setup of 3 brokers, 1 topic, 2,000 partitions, and 4 terabytes of data on each of those brokers. And the experiment I ran is to double the number of my instances, so adding 3 more brokers, rebalancing half the number of partitions, 1,000 of them. And while I was doing this, I continued to produce 90 megabytes per second of traffic, so throwing more load at this cluster. How long do you think standard Apache Kafka brokers took to rebalance? Here are the results. Let me explain this graph a little bit. The first red line is when I started the rebalance of 1,000 partitions to 3 new brokers. The second red line is when it finished. And you can see before the first red line, 3 brokers are consuming an aggregate throughput that is similar to the 6 brokers after the red line. It took about 175 minutes, that is 3 hours, to rebalance 1,000 partitions across 3 brokers. And not only that, if you can notice, during those 3 hours, my producer throughput actually degraded. And this is bad for obvious reasons. Not only was I unable to utilize my new 3 brokers until 3 hours, I also lost the throughput I was able to produce at before I added those brokers. Now let's look at how express brokers perform in this scenario. That looks so much better. The brokers just took 10 minutes to rebalance 1,000 partitions from the older 3 brokers to the newer ones. And unlike the standard broker setup, you can see that I was able to start utilizing the 3 new brokers right from the get-go. So in this way, we have built express brokers to not only offer 3 times more throughput, but also 20 times faster rebalancing, so you can handle your unplanned peaks with minimal impact to your applications. OK, let's talk about the third pillar now, redundant systems. At its core, redundancy means you have a backup of systems that are ready to take over when your primary setup fails. At AWS broadly and also in streaming, we do this in a couple of different ways. We replicate your data and your streams across multiple availability zones, or AZs, so when a single AZ experiences an outage or an impact, your applications continue to function by flowing to the other AZs. Now, we can extend this by increasing the geographic boundary to multiple regions through features like cross-region replication, where even if an entire region goes down or is impacted, your streaming applications continue to function. So I want to talk about a recent launch here in MSK and discuss an interesting challenge we had to solve during the launch of that feature. Earlier this year, we launched support for same topic name replication for Amazon MSK. With this feature, you can now preserve original Kafka topic names when you replicate topics across your cluster. Now, this was really important to our customers because using this, they get to keep their Kafka setup uniform while getting the benefits of redundancy. However, there is a challenge when replicating the same topic across 2 clusters that we have to solve for. So let's say I have a very important topic in a cluster A, and I decide to replicate it. So I bring up another cluster B, and I turn on replication from A to B. Now, a friend of mine or a colleague in a different part of the company also sees that there is a very important topic on cluster B. They have no idea that I've already replicated this, and they decide to turn on replication from cluster B to cluster A. You can see what happened here. The 2 of us have effectively created an infinite loop where the same messages are flowing between cluster A and cluster B. This leads to data duplication, and especially if this is a high throughput topic, a latency increase because there is resource exhaustion on both of these clusters. So when we built this feature for you, we made sure that it was designed to prevent infinite loops, even if you replicate the same topic across multiple clusters. So with these launches across our portfolio that focus on improving across 3 different dimensions, we continuously work towards delivering highly available streaming services for our customers. Another feature that is really important for our customers in streaming is ease of use. When it comes to streaming data, ease of use is like having a well-oiled machine. I don't want to constantly keep tinkering around, changing configurations. I just want it to work. When we think of ease of use, one might immediately think about a pretty or a fancy UI. But more often than not, at AWS, we believe there are core architectural changes like the ones you saw today with Express or Kinesis that bubble up as ease of use for our customers. So similar to availability, I want to talk about the attributes that are super important to get right to offer this experience. So broadly, again, they are choices to meet your needs, sources and sinks, and agility to get to new versions. Let's talk about choices. So when you come to AWS to set up your streaming applications, you could be at different points in your streaming journey. Maybe it's your first streaming application. Maybe you have open source affinity, you're looking for Kafka or Flink. Maybe you want reliability best practices baked in so you don't have to go through the operational overhead to figure them out. Maybe you don't just want to bring data in. You also want to process or aggregate or transform data before you get it to your destination. Or maybe you want all of these. No matter where you are in your streaming journey, we have a portfolio of services that offer the breadth and the depth of capabilities to meet you where you are. Let's talk about sources and sinks. Having a broad range of sources and sinks in core streaming platforms means that you can connect to virtually anything: databases, IoT devices, analytics tools, and so much more. And this kind of flexibility ensures that your data flows seamlessly from where it is produced to where it is needed. Why is the diversity in these integrations important? Because businesses can then unify their data systems, break down silos, and drive real-time insights across every channel that they own. So we have exciting launches to talk about in this regard, but I first want to introduce a couple of use cases or patterns that we see customers building recently, and then talk about how we want to make them easy for our customers. The first pattern is one where you have multiple applications or services streaming data into a unified data lake, either in a streaming fashion or in a batch fashion. Now, a common source that we see customers using in this pipeline is a database. This could be Aurora or RDS or even a self-managed database. Customers are looking to capture changes to this database and take them into the data lake, where they might then feed it into an AI/ML application or even an event-driven architecture. Another common pattern we see here is customers storing the data in their destination in the form of iceberg tables. Now, as many of you may know, Apache Iceberg is a high-performance open-source table format for big data analytics. Ease of use in this setup means that you don't want to go through the overhead of setting up complex ETL pipelines to achieve this end result. And so we asked ourselves, how can we make this really easy for customers to achieve real-time analytics in this pipeline? And we have done exactly that. Just last month, we launched a capability in Amazon Data Firehose that now replicates your data, changes from database to Apache Iceberg tables on Amazon S3. You don't have to go through the overhead of setting up capacity or managing and fine-tuning your clusters. Amazon Data Firehose even takes care of replicating the schema, and as the schema in your source evolves, it replicates those changes to schema as well in your Iceberg destination. And my favorite part about this feature is that you can get started with this without having to write a single piece of code. For customers who are looking to do something similar with NoSQL databases, we have also launched a DDB Streams connector for our managed Flink offering. You can use this to transform and analyze item-level changes in your DDB tables. And by the way, this connector was also contributed by AWS to the Flink open source community. OK, let's talk about another use case that we see commonly customers setting up: real-time RAG, or retrieval augmented generation for AI/ML. RAG takes artificial intelligence to the next level by combining the power of large language models with up-to-date data sources. And this makes sure that your responses are not just intelligent, they're also accurate and contextually relevant. So setting up a pipeline to achieve this in real time looks something like this. You first select your streaming data source. Maybe it's a Kafka stream, maybe it's a Kinesis stream. You then do some pre-processing. You pick a library, do chunking or filtering. They are often best practices before you vectorize your data. You then pick an embedding model from either Amazon Bedrock or a different one, generate embeddings. And once you have them, you go ahead and pick your vector database destination and where you can persist your embeddings. And at this point, you can invoke your LLMs or user prompts to do context engineering with RAG. That's a lot of steps. And this needs you to stitch together multiple services to achieve real-time RAG today. Again, we asked ourselves how we can make this super easy for customers who are looking to just get started in doing real-time insights with RAG. And just last month, we have launched a capability in Amazon MSK where we now have an automated way for you to set up this pipeline for real-time RAG, leveraging your favorite model from Amazon Bedrock and using Amazon OpenSearch as a destination. We've launched this as a blueprint on our managed Flink service, so with just a single click, you can start delivering vector embeddings to set up your real-time RAG application. We've also open sourced this code, so you can feel free to modify it based on your varying use case. Let's talk about the third, agility to getting to new versions. When you run streaming applications on an open source service at scale, staying current is not just a luxury, it's almost a necessity. And this is where managed open source services come in. They provide the agility to upgrade to new versions without the hassle of manual maintenance. And this means access to the latest features, performance improvements, or security updates for you with minimal downtime. Agility here makes sure that businesses can innovate faster, stay competitive, and leverage the power of open source without being bogged down by complexity. We have a couple of launches in this area as well. So let's talk about what's on the Flink side. We've recently launched support for the latest Flink versions 1.18, 1.19, and 1.20. We've also launched in-place upgrades using which you can upgrade your Flink applications without having to rebuild the entire infrastructure. Also, we've launched a couple of different kinds of rollbacks, system rollback and automated rollback, using which you can move safely to a previously successful version in case of any regressions with the new ones. We've also launched support for craft mode on MSK this year. As many of you may know, Apache Kafka is moving away from Zookeeper as its metadata management layer and moving to Kafka on Raft, in other words, craft. This is available from version 3.7 on MSK, and you can get started with this with absolutely no client-side changes required. So through this talk, we've looked at key areas that matter most to customers and how we are continuously innovating to deliver those for you. Now, but what does this look like in reality? To hear that, I'm very excited to invite a customer on stage who has transformed their on-prem Kafka management overhead by migrating over to Amazon MSK. So let's welcome on stage Sagar, Associate Director at Verizon, to share their story.
Hey, this is Sagar Kama. I'm from Verizon. Verizon, who we are. Verizon powers and empowers how its millions of customers live and work and play, delivering on their demand of mobility, reliable network connectivity and security. Headquartered in New York City, serving the countries worldwide, and nearly all of Fortune 500, Verizon generates revenue of $134 billion in 2023. Verizon world-class team never stops innovating to meet the customers where they are today and equip them for the need of tomorrow. We have a couple of challenging use cases which we have as in a streaming platform. So we have around several of microservices which is deployed in MSK EKS platform, which generates the logs and send it to the FluentBit. FluentBit parks the logs and filters, and it is going to send it to the Apache Kafka. Apache Kafka is a self-managed Kafka where we are using, and we have around 60 nodes and 5 Zookeeper nodes. By using the Kafka Connect, we consume the messages from the Apache Kafka, and we are sending to the OpenSearch. So these logs are sized from anywhere from 1 KB to 5 MB of the log sizes, data records. And by using the ILM, we move the logs from the data nodes to the ultra-warm nodes to save the cost. After 30 days, we're going to delete the logs from the ultra-warm nodes. This is the overall design within our infrastructure. So by using this, we want to process 1 billion transactions records per day and 120 terabytes of the data okay, and 3.5 peta of data per month, which we need to process. Scalable for retail events, we should be able to scale up and scale down based on the retail events. So for example, Black Friday or iconic launches like iPhone launches, those sort of things. So reliable real-time data processing, we should be able to process the data real time because we are using the real-time data to perform the analytics, and also we use this data actually to take the decisions around the action engine which we have. So stability of the observability platform, basically one of the data source which we are using is OpenSearch, and based on the log data, we are taking the decision around the scale up or scale downs, and under failure conditions, we are doing the auto healing and auto scaling, and also cost optimization. And we want to do the cost optimization without any data loss. We want to minimize the cost, and we want to reduce the human toil, okay, and without any data loss. This is our first use case which we have. The second use case was actually we have around several hundred of tables which we have in the Cassandra database need to be replicated from the Cassandra to downstream databases, which is Oracle and some of the NoSQL databases. We are using the open source Apache Kafka, and which we deployed in EC2 instances. And by using the EKS platform, where we have a consumer parts and consuming the messages and sending to the downstream systems like the Oracle database as well as the NoSQL databases. By using this architecture, we need to process around 3 billion of transactions per day, and it needs to do the real-time data processing because we're using this data for analytical purposes, real-time analytical purposes. And we should not have any data loss, and it needs to be performed cost optimization. So what are the issues which we have? So the first issue which we have is longer maintenance windows. So basically, as we have a 60-node cluster, around 60-node cluster, if you want to perform AMI rehydration or patch upgrades, okay, Kafka patch upgrades, we need to take one node out of rotation, and we need to create an EC2 instance. We need to swing the EBS volume. We need to bring the Kafka server up, and we need to sync the data, and we need to re-elect the partition leaders. Then by the time we complete this process, it is taking anywhere between 8 to 10 minutes. To complete all 60 or 70 nodes which we have, it is taking almost 8 to 10 hours of our time. And also, when in the iconic events, like iconic events or retail events, if we want to add or delete the nodes, it's taking anywhere between 2 to 3 hours. And the data loss due to the unexpected events, for each and every pod which we have, we are keeping the 30 MB of data, log data per container. Okay, due to more than one node, one or more than 2 or 3 nodes issues, because failures or issues, or there is any issues with between the EC2 instances, the issues related to network issues between the EC2 instances, we have seen the data loss. Because we are keeping only 30 MB of data, because ISR becomes, in-sync replica becomes 1, the client is not able to post the message, because we are keeping the min in-sync replication equal to 2, but the client is not able to post the messages. Due to that, we have a data loss anywhere between the 3 to 6 hours duration of the data. Instability of observability platform, we are missing the critical signals. The critical signals which we are missing due to the lag of the data, okay, due to the lag of the data, okay, we are missing the critical signals. Because of that, we are creating a lot of outages, leading to the system outages. And non-scalable at the time of retail events, on-demand scale-in, scale-out, which we are not able to perform by using the existing infrastructure which we have. So we worked closely with AWS team. We replaced self-managed Kafka with AWS MSK, and also we replaced the existing Kafka connector, which is running on EC2 instance. So basically, both self-managed Kafka as well as the Kafka connect, both are running on the same EC2 instance. It is actually creating a Neo syndrome effect, which is sharing the resources between each other and stepping on each other. So, and also it doesn't have any scalability for the Kafka connect because it is running on EC2 instances. Whenever I add a new partitions or whenever I delete a partitions, it is not, it is not automatically adding a new threads or deleting the threads. So that's why we moved that to the Apache Kafka connect to the EKS platform and to achieve the scalability. So due to this, okay, we were able to perform, we designed this cluster for design for failure. MSK has automatic failure of recovery, and also by design, it is multi-AZ. So by using this, we were able to achieve whatever which we need to achieve. So, and upgrades and automation of the Kafka upgrades, scaling and maintenance. So we were able to, all these challenges which we were able to solve by using this, by moving to the Amazon MSK, and as well as, by moving to the Kafka connect to the EKS platform. So the second use case which we have is actually we replaced, the Kafka, self-managed Kafka with, Amazon MSK, and we were able to move the consumer parts to the EKS platform. And also what we did was actually, we were able to scale the consumer parts based on the partitions count. So whenever we add a new partitions to the Apache and Kafka, we were able to scale based on the number of partitions. We were able to scale up or scale down our consumer parts. So the results is basically scalability and capacity. Easy scale in and scale out without any downtime. That is the first one. Network and IOPS performance issues. We don't have any network and IOPS or performance issues which we had previously. Durability and availability. Data loss was very minimal. Previously, we used to have data, it's almost like 5 to 10 terabytes of the data loss. Okay, so after moving to the MSK, the data loss was very minimal, and it was less than 0.01%. And reliability and maintenance, in-place upgrades and security patches, we were able to do without having any issues. And over the weekend, last Friday, one of the cluster actually was reached to 80%. We were able to increase the EBS volume within 2 minutes, 2 to 3 minutes. Just one command, we were able to increase the volume. Previously, it was taking a lot of time to increase the volume, EBS volume. Under security, SCRAM and SSL-based authentications. Previously, we were using the just SSL, and with moving to the MSK, we were able to do the SCRAM as well as SSL authentication. With this, I'd like to hand off to the Anusha.
Thank you, Sagar. Those results look very impressive. Okay, now we talked about a lot of launches in this session, but obviously I couldn't get to everything we've done for you this year. So I'm going to leave this slide up so you can take a picture, check out all of our launches after this session. As always, thank you so much for being our customers and providing valuable feedback that fuels our innovation here at AWS. Have a great day and enjoy the rest of your week at re:Invent. Thank you.